All right, so like I said just a little bit ago, you should be on this page that talks about cylinders. And back on Monday, when we started this unit, we talked about in the room 3D shapes. And some of you even pointed out that like this container up here is in the shape of a cylinder. So this is what we're going to be focusing on today. How do we find surface area of a shape like this? Because it is a little bit different than how we found surface area of like our prisms. The prisms, we had all of those flat polygon faces that we were using, like rectangles, maybe a triangle, maybe you had something even more weird like a hexagon or a pentagon or something like that. But we were able to find the area of all of those because they each have their own formula that we can follow. A cylinder is a little bit different, okay? Because a cylinder is made up of different shapes. What shapes are the bases on a cylinder? They're circles. Okay, so we know a formula for a circle, so like we can do that, but we needed to figure out how do we handle the curved edge? Like I can find the area of this circle. I just need to know what the radius is of this. But how do I figure out what this is? If I were to like cut my container right here on this edge and lay it flat, do you guys have any idea what shape that would make? It would make a rectangle. So when you have a cylinder, it's actually two circles and then a rectangle in the middle. And so that's what we're going to kind of look at today. So the definition of a cylinder is that this is a solid with two circular bases and a rectangular surface. So again, like we've done in the past, we'll be using our nets. The net for this one is going to look a little different than what we did with the prism. The prisms had a whole bunch of rectangles and then your bases on either side. We're still going to see something similar to that in that you're still going to have this rectangular base. That'd be like me looking at the outside edge of this. That would be that rectangle if I laid it flat. But then we have those two circles. And the circles are your bases, so I'm going to put them on either side of my rectangle. Like that. So that's what our net is going to look like. Now, when we think about the shapes that make this up, it's a rectangle, and we know how to find the area of a rectangle. That's just base times height, and height would be like the full length of this rectangle here. We've done that before the last couple of days. And then for a circle, the area is pi r squared. So I would need to know what is the radius of this so that I could think about pi r squared. There is like a formula that we can follow for surface area of a cylinder. And there's one little thing that we have to be aware of. Because this is a rounded shape to begin with, it's not necessarily a true rectangle. It's not a rectangular shape when you think about it, because it still has that circle that's impacting it. So the formula that I'm going to be using today to find surface area of a cylinder is going to be 2 pi r squared. I'm just going to stop there for a second. Where does the pi r squared come from? The circle. Why do I have a 2 in front of it? Because there's two circles. So it's already building in that we're doubling the area of the circle. You could find the area of one circle and then just double it, but this is going to do it for us. So 2 pi r squared takes care of the circles. And then for the rectangle, we're going to add that on. And we know how to find area of a rectangle. It's base times height. But because this is actually a curved shape, we have to add on another pi. So it's going to be pi times the area of my rectangle, base times height, is how I'll write that. So as long as you know the radius of your circle and you know your base and your height of your rectangle, then you're able to find surface area of these shapes. So I've got a couple examples. We're going to do the first one together, and then I'm going to let you guys try the second one. So down below, we've got two cylinders. Okay, and I'm going to be going back up to that formula here in a little bit. But the first thing I want to do is draw my net out so that I can label the dimensions of my rectangle and figure out what my radius is. So I'm going to start by drawing out that rectangle. And I'm going to put my circles on either end. Where do you guys think, based off of my cylinder, that 4 should go? Like on the rectangle?
Yeah.
So like the tall side. Mm-hmm. Okay, so 4 should go here. So that'd be this side, and that would be this side. And I agree. That'd be like if I laid out that rectangle, that's the height of the rectangle. So that'd be my 4. Okay. How long do you suppose the rectangle is?
6.
6? Where'd you get that from? The circle, right? That 6 that goes all the way across the circle, that's technically the diameter. But the diameter of the circle is going to be the length of our rectangle. So this 6 I need to use as like the bottom portion of this rectangle. Okay, so that goes edge to edge. It's a little hard to label it on there because those circles get in my way. But now for my circle, I don't want diameter because my formula for a circle did not say pi times diameter squared. It said pi times radius squared. What would be the radius? 3, because you just have to take half of 6. Okay, so my radius is 3 here. So now I should be able to plug this into my formula that I gave you up above. So the formula again said 2 times pi times radius squared, which would be 3 squared, plus pi times base times height. So again, going off of my rectangle, that's the 4 and the 6. Just like we did in the last unit, I don't really want to operate with pi right now. I just want to leave it in my answer. So I want you to just work with the numbers. So you're taking 2 times 3 squared, and then you're going to add 4 times 6. So 2 times 3 squared would be 2 times 9, that's 18. 4 times 6 is 24. So really you have an 18 pi here plus a 24 pi. We can add those together though because they both have pi's. So what's the final answer?
42.
Good, 42 pi centimeters squared still. Good. So that's really, I would say, the only main difference between a prism and your cylinder now, because they're very similar in how they look. They have 2 bases and they have this face that kind of goes around on the outside. Cylinder is just curved, and that's why we have to add in that extra pi. That's like the main difference there. We didn't have pi showing up yesterday when we were dealing with all those prisms. Okay, you guys go ahead and try number 2 on your own. All right, I've got my net drawn out here. Where should I have put the 13? The tall side of my rectangle. So this is 13. Okay. How wide is my rectangle? 5. Good. Again, that comes from your diameter. So from here all the way to the edge is 5. So what does that make the radius of your circle? Good, 2.5, because it's half of that 5. That 5 is your diameter, so you got to cut that in half for your radius. But again, we use the diameter of the circle to help us figure out how wide that rectangle is. All right, so then we're just plugging it in. So 2 times pi times 2.5 squared plus pi times 13 times 5. I'm just plugging in my radius and I'm plugging in my base and my height of my rectangle to that formula there. What'd you guys get for an answer?
70 pi 7 squared.
What did you say?
70 pi 7 squared.
I have something a little bit bigger than that. I agree with the pi and all that, but I have something a little bit bigger than 70. Ooh, not that big. What did you say?
77.5.
I got 77.5 as well. Did anyone else out there get 77.5? Okay. So check if you didn't get 77.5, check if you maybe missed like a squared or something. And don't calculate with the pi. If you're calculating with pi right now, you'll probably get a bigger answer. But it should have come out to be 77.5. Do we have any questions on how to do cylinders? Hopefully not too terrible here today. Okay, so that's all I got.